Hey guys, it's Leia. Today we're going to learn about how to solve integrals with basic trig functions. Before we go over the integral trig identities, it is important to review derivatives of trig functions and trig identities. These are the four main integral trig identities to know. We get the identities from their corresponding derivative identities. Remember from integral basics that the integral is the reverse of the derivative. We'll start with two basic examples. Our first example is the integral of negative 15 over pi times sine of x with respect to x. We can see we have a constant in the integrand, so we'll use the constant multiplication rule and we'll pull out negative 15 over pi from the integrand. Now we can see that we have sine of x in our integrand, so we'll use our trig identity and we'll replace the integral of sine of x with negative cosine of x plus c. And this simplifies to 15 over pi times cosine of x plus c, our answer. If you want to make sure the answer is correct, just take the derivative of the antiderivative and make sure it equals the integrand. Next example, we have the integral of 5 over cosine squared of x with respect to x. We see that 5 is a constant in the integrand, so we'll use the constant multiplication rule and we'll pull out the 5. Now we can see we have 1 over cosine squared of x in the integrand. So we'll use our integral trig identities and we'll replace the integral of 1 over cosine squared of x with tangent of x plus c. And this simplifies to 5 times the tangent of x plus c. Now we'll do two more advanced examples. Our first example is the integral of sine of x times cotangent of x with respect to x. Whenever we have two different trig functions, it's best to simplify both of them into sine of x and or cosine of x. So we'll simplify cotangent of x using its trig identity to cosine of x over sine of x. Now we can see that we can cross out sine of x, so we'll go ahead and do that, and that'll leave us with the integral of cosine of x. And we'll use our integral trig identity, and we'll get sine of x plus c. Last example, we have the integral of tangent of x over secant of x with respect to x. So we want to convert tangent of x and secant of x into a simpler form of sine and cosine. We'll use their trig identities, and we'll get the integral of sine of x over cosine of x divided by 1 over cosine of x. And if we rewrite this function, we can see that we can cross out cosine of x. So we'll go ahead and do that, and that'll leave us with the integral of sine of x. We'll use the integral trig identity, and we'll get negative cosine of x plus c. To get the hang of solving integrals with trig functions, it requires a lot of practice. So for more help, visit www.symbolab.com and click on the Practice tab.